This is the SAS module. So I'm on the virtual lab, and be aware that these things change frequently, surprisingly enough. The workflow for this is that we're going to actually have two frames of code, one for scratch work and one for saving. And you're going to try out code to see what works, and then you save it later. At the end, you're going to export not only the saved code that you're saving, but also your graphics will be and your results will be exported through web page format. For whatever reason, that works best here. Okay, so if you have the inclination and the time, go ahead and unhide file extensions. I'm going to skip that. You don't always need to do that. Sometimes you can get away without. So you can go ahead and open SAS. Please note there's also SAS Studio and Enterprise Guide, which we do not currently have access to. If you decide to go online and search for help, you have to be aware of that, because a lot of the guides, if you just type SAS in Google, it'll take you to the wrong guide. It'll say click these buttons that don't exist, and you'll say, what, is that SAS? Well, it is. It's just a different version. Alright, so we're going to import a file, and you're going to download it from the web at the location I gave you in the lab. But I'm going to download it from the G drive because I have it here. Alright, so it's going to say library. You don't need to change that. You can if you want. I'm going to type Dietz, so you're going to use whatever name you want. It does not have to be your user ID. It could be anything you want, as long as you're going to use it. Every time the instructions say Dietz, you're going to put your own member name there. Then we're going to be prompted to save this opening sequence, and I'm going to put this on the desktop, and I'm going to call it mywork.sas. And since I haven't unhidden the extensions, I won't be able to see that, but it'll be there. Now I want to double check and make sure my data got in, so I click under Libraries, Work, and it should be right here, and I should see my data. I'm happy with that. I'm going to close all this down. I'm going to make sure that that opening sequence was saved correctly. So this file is actually recognized by the virtual machine. I can open it. It takes a while, and I'm sitting here in this window. Whoops, I collapsed it, sorry. If I highlight certain parts of it, it will only calculate the parts I've highlighted, but if I don't highlight anything, I can just click on this little running person here and execute it. And then I'll see that my data all come back to me exactly the way it did just a moment ago. So it's all there. You should always close down your view table when you're not actively looking at it, because if you leave it open, you cannot write to it. You might want to make changes to it. When it's open, it's locking out the ability to change anything in it. So be aware of that. Okay, we're already on page 2. Alright, I want to save my work, and I recommend that you just keep tacking on in here what you want. So you could just put a comment here, your name, whatever you want, and then keep putting things in here. If you hit Control S, you'll save the changes to that, or you can export it as an SAS file. Either way, but if you're just using it, you can keep hitting Control S, or for Apple users, your analogous command. And if you see this little star disappear, see there's a star, and I hit Control S and the star disappears, it means you've correctly saved it. Okay, so now I'm going to make a new window. I'm going to say window, new window. And I'm going to just get rid of all this stuff because I don't need it. Right? So I'm going to just write whatever I want in here, and then I'm going to execute it. So it's kind of like my scratch pad. And then everything I want to save long term, I'm going to put in my work over here, my work 1 versus my work 2. Okay, so for these various exercises, I'm going to give you a little snippet of code, and I want you to just type it in and execute it. So for example, I'm going to create a new set of data actually. Now I'm going to just hit run. So just to be nice to you, I'll usually, but not always, indent these as follows. This is the standard default way we do things. We usually just inputs. I don't know why it's echoing down here. Whoops, no idea why. That is a mystery. I did not expect that. Anyway, I'm going to run this, but SAS is a language where spaces don't matter. Indentation doesn't matter. It's just there to make your life easier. Anyway, if you look in the view table, we have a single variable x with, it's actually a whole column of x's, but it's only one row of observations, so that's pretty pathetic. So that's why we only have a single 10 there. Okay. Now let's figure out how to make a pie chart. All right. So instead of creating new data set, we're going to use a set we already have. And the way this typically works is most of the commands we're going to run start with the word proc. So proc is a procedure, and we have a procedure called gchart that we're going to make use of. You can type work.deets or just deets usually, or whatever your name is. You don't always have to preface it with work. So it depends how much of the path you want to specify. Once you're down in there, you don't have to be as specific. But I'm just going to do it that way to make it easier, more consistent. Okay, if I want to make a pie chart, I'm just going to make a pie chart out of my legs. What does that mean? Over here, legs, you don't know what it means, but there's zeros in there, 15s, 24s, whatever. There's things in there. Okay, so there's numbers in the legs category. It's how much, actually what percentage of their body is covered by virtue of their legs is really what it means. But let's go ahead and make this pie chart. And we have this beautiful little pie chart. You can do all sorts of tweaking the options to get different colors. This says 366 observations. We said their legs were fully covered. For 21 people, then 27.5% of their body was exposed because of their legs, and so forth. This is whether they had like pants, or if they had like shorts or skirts, things like that. Okay. I'm going to go back to my work. So summary statistics. I want the 25th percentile and the median, which is also P50, and P75, so the 75th percentile. These are also quartile 1, 2, and 3. And right now I'm going to show you that you don't have to put this in this nice format I had before. You can just run everything together. You get that. Okay, what if I wanted to split it by gender? Well, that I can put right before the run command. I can say class male. A lot of times it doesn't matter where you put this. If I say class male and I put it, say, here, it may or may not still work. So sometimes it matters, sometimes it doesn't. But anyway, let's go ahead and split by gender. And then we get, as you can see, here's our summary statistics without splitting by gender and summary statistics with splitting by gender. All right. All right, so we're going to move right along to the third page and figure out how to create a new empty variable. You can make comments this way. Set work deets. So what that means, I want you to think of set as a noun, not a verb. It's not talking about a set, it's talking about set this. Set work deets. And we're going to loop over that, and we're going to create this new variable I'm calling new var, but I want it to be empty, but we kind of cheat by just putting a period there. It just means it's empty. It's not really cheating, that's just the way you do it. In statistical software, sometimes we use a dot to mean missing data. Okay, so I want to create a completely new variable with nothing in it. First of all, make sure that you have not opened the data frame or you won't be able to write to it. Okay, looks good. So I'm going to click and run, and then I'm going to peek after it's done to make sure it worked. And I'm happy. It's in there. Great. Make sure you close it. Alright, now what? Well, what if I want to see how big my data frame is and I don't want to scroll? How can I find that out? This is pretty pathetic, but this actually works. I say it's pathetic because you think it would just be easier than this. Okay, so what does this mean? It means we're going to use the same data set we've been using. Knobs means number of observations is n, and then I want to put that on the screen. But if I don't put stop, it's actually going to loop over this entire set of data. So however many rows of data, it's like 500 or something. You're going to have 503 copies of the number 503, which is really silly. So you only need to do that once. So ironically, in order to print something, you have to say loop over the entire data set, but then stop after the first round. It's just kind of dumb. But that's, again, that's just, it is what it is. You get what you get and you don't get upset. Where's my log? There we go. 503. There were 1 observations read. Yeah, because I stopped you as soon as you started. Duh. That's why. Okay. That's why it stopped. Because I stopped it. Great. So we know there's 503 elements in the data set, or we could just crack open that file and scroll down at the bottom and see that there's 503. Okay. What if you want to create a random set of data with a normal distribution? Fine. Give it a new name. Here's how we do a loop. Let's make 200 elements, and we want x to be 100 plus 15, so 100 will be the mean. And you would think that you didn't have to fill anything in, but you need a seed value. So I just run my finger along the top of the number keys. I don't really care. Just make sure there's something in there. And then we want to end off our loop. And we want to go ahead and run this. And we end up with a new set of data called new name. And it's just, that's all it is. No big deal. It's what you think it would be. Okay, what if we want to create grouped frequency histograms? Histogram of exposure. And let's go ahead, group it. If we don't want to group it, we just leave out that little bit that says class male and it won't be grouped. That's easy enough. Run this. And look at our output. Well, I guess that's not what I look at my results viewer. And we've got a whole bunch of stuff we didn't need. Hold on a second. Just have to figure out how to, I'll be back in a second. Okay, so here's the graphic we were looking for, and then there's a whole bunch of other stuff that comes with that. What if we want a confidence interval? You have means data equals whatever alpha, you set the alpha, whatever confidence level you want, you put it there. CLM, this is confidence limits, I think. I don't know what it means, but CLM works. Var exposure, so on the exposure variable, we're going to do that. Alright, and you get the lower and upper limit of that you were looking for. Okay. Okay, so what do we do for correlations? We want a correlation matrix? Let's do it. Let's do a correlation matrix on exposure, C, and TPH. You could just correlate two things. You could get a 2x2 matrix, but that's kind of sad. You know, you may as well at least get 3 variables in there. Okay, so we have our 3 variables, and notice things are perfectly correlated with themselves. Big shock. C is the current temperature, and TPH is today's predicted high. We should not be shocked that those things are highly correlated. It would be very, very sad if they were not highly correlated. And if exposure were not correlated with these things, then the whole purpose of having the data would be kind of sad too. Like if people did not dress according to the weather, I would be completely shocked. Okay, what about QQ plots? Proc univariate data var exposure QQ plot and run. Go ahead and run this. Okay, so I'm going to just go ahead and let you finish the rest of this exercise. I'm just going to talk a little bit about this. You're going to create QQ plot and some scatter plots. For the scatter plots, it looks like a lot of code, but a lot of it is just changing a tiny little thing. So in your workspace, don't change everything, just see what's different. Don't erase it. So if you don't erase it, you won't have to type it again. So most of these are just cut and paste. But then there's this big block that says proc gplot data equals blah blah blah, and for that very last one on the bottom of page like 4, I guess, there's just a lot of typing. I just wanted to make a point that the star is not multiplication. It is saying that exposure is plotted against current temperature. So it's an operation. It's not, it's saying that one is on one axis and one is on the other. It's not multiplying them together. Okay? And then if you flip over to page 5, we're going to recode the variables. That should not be difficult. Define female first and then male. I don't know why, but if you do it the other way around, you end up with issues. I have no idea why. For the scatter plot that has regression lines for each subgroup, it's a little different. So go ahead and type that in and see what happens. Then the last little bit on the bottom of page 5, it says making a sorted line plot. That part is a little bit convoluted because in order to, what I want to do is sort the exposures. And so I have to sort it into a new data frame and then bring it back in again. So I just show you how to go through all that. And ANOVA should be no problem, chi-square should be no problem. Now, I do want to show you how to save your work. So what you do is you say File, Save As, and I want you to save as I'm sorry, I was in the wrong window. I have to be here. I have to be in the results viewer. If I follow my own instructions, it would be fine. File, save as, and then I get the right thing. Okay, so I need to save as web page complete, save, and then it should, a little folder should show up on the desktop. But it didn't because I didn't tell it to put it on the desktop. So we do that again. Or you can just drag it over from wherever it came from. And I'm going to save again as in the desktop again. And I'm going to save as a web archive. So I'm going to save both of those. And then I have both of those. I'm also going to, if I haven't already, I'm going to go over and save my work. So I'm going to just hit Control S in this case. But if it would be a window where you had all the work you wanted to save. Here I've just erased and erased and erased. But if you're doing this for a project, okay, so we have the web page complete and we have the single file web page, and you're going to save your actual code in another file. So now you should be able to close everything down, and if you do it correctly, you should be able to launch from here and reproduce all your results again. You should see in here is all your graphics should show up in here in your web page complete folder. That's why I asked you to do it, so you'll have your graphics for later. And then over in this file, it just looks like a web page and everything is together. It just looks like your everything you did in your output. And you just scroll through and see it. Okay, and so there you go. That's all you need. And so if you're doing this as something to hand in, you need to do all the things that are listed in the bullet points in the handout and save all these results. So everything here, all these 3 things, whereas don't forget this is a whole folder full of things. So you'd have to, if you're sending this through Blackboard, you can upload the graphics as separate files or zip them together if you wish. And then you're going to have this file and this file, you're going to put those up as part of your submission. Okay, let me know if there's any questions. I know these things are, I'm giving you more and more work to do on your own. I'm giving you less and less guidance at each of these levels. So if you need more help, just let me know. Thanks.